Do you hear me well?
Yes.
Yes.
Okay, I'm going to share my presentation. Just a minute, please. Okay, could you see my presentation?
Yes.
Okay, well, my name is Ernesto Castillo. I am a software engineer, and I am here on behalf of ALeRCE team to talk about our infrastructure. I want to emphasize that this is a collaborative effort for all of my colleagues. First, I want to talk about the hardware that we rely on. We work on the cloud using Amazon Web Services. We were given some credits through the Center for Mathematical Modeling of University of Chile. And in the near future, we are going to have these credits through the Data Observatory organization. On the other side, we work on premise. We have some hardware on the Reuna network that we are planning to augment using some KML funds that we earned last year. We also use a cluster that is located in the National Laboratory of High Performance Computing here in Chile. In this diagram, we can see an overview about the main building blocks of our infrastructure. The ones of color are going to be discussed in more detail in the following slides. I want to start with in the left side with the Kafka server or service. That is a distributed queue system, and that's the way we how we ingest all the nights the data coming from CTF survey. We put all of the data in our pipeline, and we process all of the information at the different steps. We store the processed data in a database, and the raw files in a storage service in Amazon Web Services. All of this data then is accessible by means of different APIs. So an external user can access this information in a programmatic way using the API, or also use our different frontends, as Francisco said, the CTF Explorer and the Supernova Hunter. So this frontend requests the API, and in turn, the API requests the database or the storage system. And at the end, we also have the batch processing unit. So we can perform computations using the entire historic data of CTF catalogs and other catalogs as well. I want to mention that currently we are working in the transition to a new version of our infrastructure. We have been working, making significant change in the pipeline, in the database, in the API, and in the frontend. So the new version have a better design, is more modular, flexible. So because of that, easier to change and maintain. Well, I'm going to start talking about the first building block, that is the pipeline. My colleagues, especially Camilo Valenzuela, Diego Rodriguez, and Javier Arredondo, have been working a lot developing the alert processing framework, the APF. And this framework is based mainly by three technology: the Kafka distributed queue system, the Python language programming language, and the Docker container system. Each of the steps perform a specific task. For example, do some cross matches, compute features, and perform some classifications. Each of the steps is programmed, developed in Python, and encapsulated in a container, and communicate between them, among them, through the Kafka system, using the topics or the streams, the different queues that this system has. This is a main advantage because you can run the different steps in different machines if you want across the world. So, for example, if you want to implement a custom step, you will need access to one of the topics, or one of these topics or queues. And you can implement, for example, custom filters, custom classifiers, custom watch lists, or any notifier as you want. The job is is facilitated by the APF framework written in Python, but you can also implement a custom step in a different language as you want. Another building block that we use is the storage service. we use the Amazon Web Services S3 bucket. S3 stands for Simple Storage Service. It's a easy way to upload and download objects to this bucket by means of an identifier. We have different catalogs there. We have the raw data from CTF that we receive each night. We are working also processing the CTF data release 3, Gaia, and other catalogs. We also have the content of our different websites, some backups, and different archives. Another building block of our architecture is the database that is implemented now in the PostgreSQL engine. This is the schema for the CTF survey. At the center, we have the astronomical object table that is related with the other tables. In yellow one, here at the left side, you have all of the information related with external catalogs. At the center in green, we have the information related with light curves, with time series data that we receive each night. And at and at the right, we have the information related with statistics, features, and probabilities related with the classifiers that we employ. Another building block, important building block, is the different API that we have, the application programming interface. This schema shows a basic example how API works. For example, if you want to access information in a database of, in our case, in the S3 bucket storage service, you can implement this API that is a kind of way to interact between programs or systems, and deploy this in a server and start listening to any request. So the different clients of different types of language can request information through the API or this interface through the data. For example, in the case of the Supernova Hunter, one of our web interface that is deployed in JavaScript, is implemented in JavaScript, can request data through the API and show the information in the web page. We also have a Python client that access the different APIs that we have. Or if you want, you can implement a custom client in different language and interact with this information. So we have the different APIs for different features. For example, you can access the database through this API. You can access the raw data, the Abro files, and the stamps also with this other API. You can perform a concert and cross-match through the CATS HTM library. You can request a finding chart and also the TNS database. This is the documentation of the ALeRCE client written in Python, and this is the link that you can follow to use it. Another building block is our different frontends. Thus, in this case, this was developed mainly by Diego Rodriguez. This is the newer version of the CTF Explorer in a dark theme. But also, he has developed a component library that encapsulates the different components. So it is easier to create a new kind of web page reusing the previous components. So it's a very nice features to have. And finally, well, we also have this batch processing building block. So as I told you, we use the S3 bucket service in Amazon to store the different catalogs, and also in Amazon we can use a cluster of different instances using sparse SQL to process all of the historic data in a matter of minutes. If we want to process further this information, we can also use the cluster that is present in the National Laboratory of High Performance Computing. Some of the use cases that we can do, as I told, processing CTF historic data that is about 4 terabytes of size, maybe performing some cross-match between massive catalogs, or analyzing LSST hits alerts to mention just a few just cases.
5 minutes.
Okay, thank you. This slide tells about further development that we want to do. one of the first topic is to scale our current database that is implemented in Postgre to a distributed database like Cassandra. We have been making some tests, but we need to do more tests about that. Another thing is to use Kubernetes to manage the different Docker containers. We also want to integrate the batch processing in only one cluster. And we are starting also asking us how to deal with multi-stream astronomy, because currently we are ingesting CTF data, but in the near future we are going to ingest also, we are going to start ingesting also the ALeRCE survey, and in few years more the Rubin Observatory. So one big question is how to deal with all of these streams in parallel. And also, well, in the case of a cross-match service, we want to have a faster and up-to-date cross-match service. So we are discussing if we are going to implement our own system or use another system that is provided by any other broker or any external facility. So finally, as a summary, as I show you at the beginning of this presentation, this is the main building blocks of our infrastructure. The pipeline that has this powerful feature that can be run distributed in any place. We have our database, our storage service, the different APIs, the frontends, and the batch processing unit. Thank you.
Thank you, Ernesto.
I don't know if, yes?
So there is a question whether other software could be Julia.
Sorry, what is the specific question? I am reading right now. We are not using Julia, but Davis.
So whether we're using Julia. And here,
why don't we use Julia? Or
whether we were using Julia, but no, we are not using Julia. But there's another question. What are the limits for downloads from the database? Does the API allow to download millions of record sums, which is important for machine learning? And two, is there any systematic testing of the usability of interfaces?
Well, about the first question, there's a limit. I think that it's about not it's on time. It is put it on time. I think that maybe 10 minutes. I'm not sure. Maybe my colleagues Diego or Camilo can reply that question. But there's a limit on time. So if the query lasts more than that time, you wouldn't be able to download all the data. But if you want to download more data than that, you can contact us and we can share with you the specific amount of data. And the systematic usability of interface. We as far as I know, at the beginning of the developing process of the interface, some usability testing were done, but maybe we need to do more current tests of usability of our interfaces. I don't know if there's another question or.
Here's a new question. Do you know how to make SQL queries? How does this barrier affect your work? I think this is to the other participants. So if other participants can reply, it would be interesting to know.
Oh, I can see another question here from Alvaro Valenzuela. What is the advantage of using Python instead of other language in ALeRCE? Well, Python is an scripting language that currently is mostly used in data science community. Most of the astronomers know how to program in Python, so it is faster to program in Python. It is not the fastest program to run things, but in that case, if you want to run things faster in terms of in terms of performance, you can develop, for example, a model in C or in other language, in C++, and make an interface between the Python and that model. Actually, one of our colleagues did that with some computation of the features in order to classify that information.
Yeah, I think Ernesto, we need to move on to.
Okay, yes, please.
Guillermo, thank you very much.
Okay, thank you.
Guillermo?
Hey.